Hi, I'm Willow Chandarina, Product Manager with the Amazon Elastic File System team. I'm joined today by Jake Farrell, Senior Director of Engineering with Aqua. Today in this reInvent session, we're going to be talking about modernizing applications using Amazon EFS and containers. We're going to start out by talking about why and how to modernize your applications using containers, and then how to get started. First, how to get started configuring EFS for your containers, and then how to configure your containers for EFS. Then I'm going to pass it off to Jake to talk about how Aqua modernized their applications using containers and EFS. Before I get started, I just want to point out that EFS has a lot of sessions at this reInvent. I'd encourage you to check out the course catalog and view some other ones if you enjoyed this session. So now let's get started with basics of modernization. So let's start by talking about why modernize your application. There's three key benefits that customers get when they modernize their application using containers. First, because most applications are elastic in nature, demand goes up and down during the day, or certain events cause surges of traffic. You want to make sure that you have a compute infrastructure that's able to quickly adjust scale to those demands and meet your business objectives, and containers offers that to you. Next, most companies that adopt containers also modernize their application development processes and adopt things like continuous integration and continuous deployment, which helps deliver features to market faster, making you more competitive. And last, because with modernizing with containers, you're using fully managed services for both the compute and the storage, you can offload more of your operations to AWS, lowering your costs. Now, AWS offers a spectrum of choices when it comes to how to modernize your application on the compute side. On the bottom end of that spectrum, there's Amazon EC2. With EC2, you have the most control over how you want your application to run, but also you manage most of what your application does. So AWS manages the physical infrastructure, you manage the operating system and above. On the far other end of the spectrum, you drastically simplify what you have to manage because AWS manages everything but your business logic, which is in your code. Now, in between Lambda and EC2, there's containers. And with containers, you manage the application code, you manage how it interacts with other AWS services, you manage aspects of the network configuration and the monitoring, and AWS manages either the physical hosts and orchestration infrastructure, or in the case of AWS Fargate, it even manages the deployment of your containers and the scaling of those containers. In the rest of this session, we're going to be focusing on this middle part with containers and EFS. So let's introduce what EFS is. EFS is simple, serverless, shared storage for your AWS applications. It's simple and serverless because it's a fully elastic service. You never tell EFS how much data you're going to store. You only pay for how much you store, and you never have to resize your volumes. It is highly available and highly durable. All data that you write to EFS is persisted to at least 3 availability zones and available from all availability zones within your region. It's scalable. It's scalable to petabytes of data in a file system. It's scalable to tens of thousands of connections per file system, gigabytes per second of throughput, and hundreds of thousands of IOPS. Last, it's cost optimized. It's cost optimized because there are 2 classes of service. One is EFS standard, which is for frequently accessed data. The other is called EFS Infrequent Access, and it's 92% lower cost for data that you aren't frequently accessing. We have lifecycle management that moves data automatically from one class to the other and helps you optimize your overall storage costs. Now, the customers that modernize typically start with an application that's running on a server, either on premises or in an EC2 instance, And that application is connected to some persistent storage, either a storage area network or network attached storage. Now, when you modernize that application, first you put it in a container, and then you use Amazon Elastic Container Service or Elastic Kubernetes Service to orchestrate the launching of that container. And then you would launch it either on EC2 instances that you manage, or use AWS Fargate to manage the instance lifecycle and container lifecycle. No matter what you choose for AWS Fargate or EC2, ECS or EKS, for the storage component, you would use Amazon Elastic File System in order to persist the data for your application. In doing so, you're able to have a fully serverless compute and storage infrastructure. So now let's talk about why you might need persistent storage for your application. Typically, applications would need persistent storage for one of two reasons. First, applications that are long-running and stateful in nature would want persistent storage to ensure that if the container restarts, moves to another instance, or moves to another availability zone, any data that had been written would be available to the newly started container instance. The other reason would be you have an application that needs to scale out around a shared data set or share data between different applications, such as a data pipeline. Some examples of existing applications that this is relevant to include developer tools. Developer tools like Git, Jenkins, Jira, Artifactory, and so forth all benefit from the persistent nature of EFS to ensure that your CI/CD pipelines and source code are safe no matter what happens to your containers. Next, content management systems are very commonly containerized. So things like WordPress, Drupal, Nginx, Apache all benefit from the persistence to make sure that your web assets are safe, but also from the scale-out nature of shared data, because when traffic goes up on your website, you're going to want more web servers, but they all need to have access to the same static web content, and EFS gives you that. Next, with machine learning, you commonly want to train more models at the same time, or train models faster by parallelizing across multiple containers. And by having a shared data set in EFS, you can do that in parallel across many containers. And last, in those data science environments, many of the tools that you want to deploy, such as notebooks with Jupyter and Jupyter Hub, or ETL tools with Airflow, benefit from the persistence of EFS. Now, when you combine EFS with the managed container services in AWS, Elastic Container Service and Elastic Kubernetes Service, many of the benefits either line up or magnify between them. For instance, the simplicity. So all of these services are fully managed services, which means by using these container services in EFS, in many cases you have no infrastructure to manage, which drastically simplifies your environment. Next, we've done these integrations in such a way that enables you to put all of the storage configuration in the place where the developer is going to be managing it, either in the ECS task definition, the pod spec, or similar. So you ensure that your developers are focusing on their applications rather than the infrastructure. Next, the availability and durability of these services line up nicely. These are all regional services, which means your applications can take advantage of multiple availability zones, and so can your file system. So you never have to worry about where your application is going to spin up because the data is everywhere it needs to be. The elasticity of all these services goes well together, not only because you can scale all of them together, but also because you can scale them separately. For example, you can scale up and down your container fleet while having your data stay in place, so you can essentially scale your applications down to zero while having your data in place. And last, we've integrated these services together in a way that is secure with cloud-native functionality like IAM and a new capability we launched this year called Access Points. So now that we've walked through the background of why and how you would do this, let's get started with modernizing your applications with EFS. Now, starting with just the checklist, what we're going to be covering in this section is first how to set up your file system for security and identity, how to optimize performance, how to optimize cost, and then set up data protection. So for security and identity, most customers have two core goals. The first goal is to ensure that their data or their file systems is only accessible from the applications that need it and not those that don't. The second goal is whenever you have a shared file system, you want to make sure that your applications have access to the data that they need, but not access to data they don't. So in the first case, it's access to whole file systems. In the second case is how do you make sure that data within a file system is properly authorized to applications. Now for the first goal of how to make sure that you can have coarse-grained access to file systems from applications, we've integrated EFS with AWS Identity and Access Management, IAM. And you can use IAM policies to authorize applications into file systems. Now, currently, this is a functionality that's only available with ECS. With EKS, there are other ways to control authorization, like role-based access control and namespaces. But in this section, we're going to cover the ECS way to configure this. So when you set up IAM Access, you can do it in one of two ways. First is you can use an identity policy. So you can have a IAM role that's associated with your ECS task. It's called a task role. And on that role policy, you can grant access to one or more file systems in your account or even in another account. The other way that you can control this is from the file systems perspective using a resource policy. So on the IAM policy on the file system, you can configure one or more roles that have access to it. You can also use both of these together in case you have more intricate policies that you need to enact in your organization. Now, diving a little bit deeper on this, there's a few different actions that you can authorize for file systems. First, there's the client mount action. With client mount, essentially what you're doing is giving read-only access to the file system from your container. If you want write access, you can add another action called client write. With client write, you can read data, you can write data, so long as you aren't doing so as the NFS root user or user ID 0. If you try to do that, what's going to happen is all of your operations are going to get marked to a different user called NFS nobody or 65534. So this protects you from applications that may try to access data that they aren't allowed to access. And last, for those applications that you completely trust on your file system and want to have full root access, you can add the action of client root access. So the three of these together, or you can just do client star, would give you full access to a file system. So that solves number one of how do I make sure that I have access to a particular file system from my application. Next, let's talk about how to have access to specific data in a file system from your application. And to understand how this works, let's assume that there's already a file system set up. So this file system has 3 directories. It has a directory called Bob Home that's owned by user Bob, a directory called Maria Home owned by user Maria, and a directory called BI Shared, which is owned by a group called BI Users. Now in this case, I'm going to connect to this file system from a container that I just downloaded from Docker Hub. And in the case of this container, it was built to run the application inside the container as user root. And what we're going to see is when that container connects to this file system, it's going to be able to access anything because it's going to be doing operations as root, which as far as the file system is concerned means they're able to access whatever they want. So the key thing to understand here is with containers, the identity comes from how the container was built, not how you configure the runtime of that container. And it's this property that led us to develop a feature called EFS Access Points. With EFS Access Points, you're able to control the identity and the home directory of applications as they come into the file system. So to understand this, let's look at an example policy. So the 2 main things that you see in this policy is an object called POSIX user, and that in this case has user ID of 123, group ID of 123. So the importance of this is any application that uses this access point to connect to the file system will have its operations rewritten to this user ID and group ID. So it doesn't matter what the application or container is trying to be. This is how the application is identified and authorized on your file system. The other thing that access points do is allow you to put your applications into a root directory other than the default of the root of the file system. So it gives you a private space for each of your applications if you choose to do so. And not only can you put that application into a private space, you can even, using creation info, ask EFS to create that directory for you, so you don't need to have any external provisioning infrastructure as part of your application. So again, the two key things that you're able to do with an access point. First is enforce file system identity for containers that might be running as root to make sure that they aren't accessing everything. And for the cases where a container might have been built with an arbitrary user ID of 21212, you can mount that to something that's meaningful to the data on the file system and make sure that the container has access to the data that it needs. Next, it creates application-specific directories and even pre-creates them for you, simplifying the process of deploying your applications. Now, just graphically how this works, you connect your application to your file system through this access point, and then all of the operations that that application is performing get rewritten to the identity of the access point. Or if it tries to read from what the application thinks is the root directory or slash, it gets remapped to that of the access point. Now you might be wondering at this point, how do I make sure that my particular application can only access the file system through a particular access point so I can enforce a specific identity? And in that case, you can also use an IAM policy and a condition key. So by specifying the access point ID in the condition key, either in your identity policy or your resource policy, you can ensure that you have a strict mapping between a particular application with a role and a file system with an access point. So just overall best practices for security. I'd recommend you use access points even if you have a single file system, single application per file system. And when you configure it, make sure that you don't leave any of the fields blank. Explicitly configure a user ID, a group ID, and a home directory. Doing so future-proofs your file system for any application that might come after it in case the user ID changes. Next, use IAM authorization if you're worried about which applications can access which file systems. It's much easier to manage than network-level permissions like security groups. Last, go ahead and enable encryption at rest on your file system at creation time and encryption in transit. Both of them are really easy to set up and have no performance penalty. Next, let's talk about performance. Now, this year was a big year for us for performance because we launched two key performance increases. One is for general purpose mode file systems, we increased the I/O operations per second, or IOPS, by 5x, or 400%. Next, we increased the per client throughput by 2x, or 100%. So in this case, applications can do a lot more IOPS, they can do a lot more throughput, which means you can put more types of applications on EFS. Now, for how to set up your file system to get the best performance, my recommendation is to use general purpose file systems for nearly any application that you put on. It now supports 35,000 IOPS, which is more than most of the applications are going to need, and because it's going to give you the lowest per operation latency for what you're doing. The only case where you might want to use a max IO file system, the other type, is if you have an application that scales out to hundreds or thousands of containers that are all operating on different files or directories. Next, use provision throughput to ensure that you have the right amount of throughput for your application. When you configure provision throughput, if you're ever in a state where you would be entitled more throughput based on the amount of data you have in your file system, we give you the higher of the two and the better cost of the two. So it's a great practice to start out by configuring provision throughput on your file system, and then as your file system grows, you kind of grow out of it. But you always ensure that you have the minimum throughput you need for your application. And last, make sure you're monitoring your CloudWatch metrics to ensure that you're not hitting your configured throughput limit, or if you're in bursting mode, you're not running out of burst credits. Customers often ask when they should use EFS versus EBS. Now, the easiest way to make this decision is if you have data that needs to be shared, by default, use EFS. EFS is a shared file system versus EBS, which is intended to be single attached. Now, in many cases, you might still want to use EFS for single attached data because you want your application to be able to move between availability zones. In other cases, the high IOPS and very low latency of EBS might be attractive. So in the case of a relational database like MySQL, it may make sense to use EBS. Amazon FSx for Lustre is another choice for application storage for the cases when you need super high throughput, like tens or hundreds of gigabytes per second in aggregate across a lot of instances of an application. Make sure you're optimizing the cost of your file system by turning on EFS Infrequent Access. It's now on by default when you create a file system from the EFS console. And the way this works is each file system has a lifecycle policy associated with it. It can be low as 7 days, as high as 90 days. And if files haven't been read or written within that period, we move that data to 92% lower cost storage, EFS Infrequent Access. Now, most customers that enable this feature get a blended storage cost of 8 cents per gigabyte a month or less. So there's a huge advantage in turning it on. And last, it's so easy to ensure that your file system is backed up by using the AWS Backup Service. You can establish a backup policy, which takes a backup every day, saves it for a week, takes it every month, saves it for a year, and automatically life cycles those backups from warm storage to cold storage. So you really want this to be in place in the case of an application that deletes a data that it shouldn't, or a user makes a mistake. You can always pull your data back if you have this configured. Now let's talk about how to connect your containers on the ECS or EKS side. Starting with ECS. So with ECS, everything about this configuration is around an object called EFS Volume Configuration, and it's all at the task level. Now, the way that you would configure it from the console is you would click the button in the console for Add Volume, select EFS for volume type, and then make the choices that you want for which file system, which access point, whether or not you want encryption and IAM to be turned on. Then you would simply go into your container configuration and reference that volume that you just configured and say where inside that container you want your file system to be mounted. After that, you're done, and you can just launch your container and it will use EFS. Here's an example of what the container definition would look like once you go through that process. You can see here that there's a volume set up with EFS volume configuration and all the choices that we made, and that is referenced in the mount points of the container definition. Now on EKS, there is a framework called the Container Storage Interface, or CSI. And EFS has a CSI driver which allows all of the tooling and APIs that speak CSI to speak to EFS. So the way that you would interact with EFS is in the terms of a storage class, a persistent volume, and a persistent volume claim. And the easiest way to explain this is just to walk through an example. So first, for installation, there's a single command that you would use to install the driver if you're doing EKS on EC2 instances. With Fargate, we take care of that for you. Now to the first step that you do if you want to attach storage to your container is you create a storage class, which in this case just says that you want to use the EFS CSI driver. And then you create a persistent volume, and this is where you link your persistent volume to a specific file system. So in this case, you reference a volume handle. And the way you use volume handle and this change recently with the 1.0 of the driver, is you can either put in a single file system ID, or you can use a colon-separated object to say a file system ID, and an access point, or a file system ID, an access point, and a subdirectory. So you can use all of these together to get as granular as you need for your persistent volumes. In most cases, what you're going to want to do is create a file system, create several access points on that file system, and have a persistent volume for each one of those access points. Because what you're doing is you're building a pool of storage that will be available for containers to claim as they need it. So to claim that storage, the first thing that happens is a developer comes along and they open a persistent volume claim. The only thing that they configure in that case is they point to the storage class. And what the Kubernetes scheduler is going to do is find an available persistent volume, one that you'd already created, from that storage class. And then they would launch their pod or their service referencing that persistent volume claim, and now their application has storage. So now that I've walked through all that, I'd like to hand it over to Jake to walk through how Aqua used containers and EFS to modernize their architecture. Jake, take it away.
Thanks, Will. My name is Jake Farrell, and I'm the Senior Director of Engineering, responsible for the core platform teams that power and run Aqua Cloud. I would like to start with a little background on who Aqua is and what we offer to help frame our needs for a resilient file system like Amazon EFS. At Aqua, we believe in the power of community and giving our customers the freedom to innovate and build impactful experiences as they see it. Open source is built into our DNA. Our CTO, Dries, wrote the first lines of the content management system Drupal and created a community and company around that project. That belief of open transcends our company today and has led Drupal to be one of the world's most popular content management solutions for enterprises. Our business has expanded to not just include Drupal, but complementary offerings from core search capabilities to machine learning, personalization, all the way to marketing campaigns and customer data management. We are the #1 contributor back to the Drupal open source project, and many of our employees are highly engaged in other open source communities. Customers come to build their digital experiences on Aqua because we provide the most secure, easy to deploy, simplest to manage platform that is ready for scale when the moment counts. Some of the largest media companies run their infrastructure on Aqua, including Warner Music and NBC Sports. With over 30,000 sporting events each year, managing content can be a challenge. From golf to the Olympics, NBC reimagined the fans' experience and raised the bar. At the last Summer Olympics in Rio, NBC Sports with Aqua saw 3.3 billion total streaming minutes served that were viewed by over 100 million unique visitors. In the food industry, Wendy's partnered with us for their digital transformation to move faster and gain better customer insight for their web and mobile orders. Utilizing machine learning, the Aqua personalization service has helped Wendy's engage at new levels with their customers, like A/B testing for different featured product combinations on their website. But let's be honest, Frosties go with everything. In retail, brands like Lululemon are building stronger relationships with their customers by bringing together online and in-store data to create holistic, personalized customer journeys. Aqua is in the business of creating digital experiences. The largest organizations across every industry, from entertainment, retail, education, and government, trust Aqua to securely run and scale to meet their needs when it matters. So what powers all of these digital experiences? The Aqua Cloud Platform is a reliable, cloud-native platform built from day one on top of AWS that meets the highest security and compliance standards for developers. To support our customers' workloads, we are active in over 70 AWS accounts in 10 regions today. Knowing what our customers are creating, let's focus on what it takes to store all of that content. We house over 6 petabytes of static storage for customer content served to the end users. Our systems buffer, stream, and archive upwards of 5 terabytes of mission-critical logs daily for varying compliance levels. In addition, our services have their own unique storage needs, like our personalization service, processing billions of transactions daily, generating over 500 terabytes into our data lake, all coming from over 4,000 customers with 50,000 developers creating and running thousands of sites on the Aqua Cloud platform. Let's dig into what makes this possible. At its basics, Aqua Cloud is a LAMP stack that is split up by component for resiliency and scalability. Our storage journey started, much like many others, with the application persistence layer for the web tier running directly on EC2 instances mounted by EBS volumes. As the workloads moved to be more dynamic, we transitioned to running Gluster clusters as our scalable data file system. This is managed from our custom control plane and homegrown task system that configures and runs our fleet. Gluster clusters are spun up and configured using Puppet to install common packages, while we rely on our task system to perform the necessary disk management and disaster recovery functionality. Even with automation, Gluster comes with its own set of operational challenges, like managing data bricks to grow and shrink volume sizes. This can be difficult at times and can lead to issues like clusters experiencing split brain, where a replicate has become out of sync, which ultimately can result in a loss of data, having to work through complex healing and time-consuming recovery procedures. We are always looking for ways to improve, evolve, and exceed the expectations and demands of our customers and their workloads. Our platform has been expanding in the use of Kubernetes, and while this has been happening, we took into consideration all the operational challenges of Gluster we had faced and started looking for alternatives that would meet our needs. We needed a POSIX file system that was easy to set up and maintain, was secure and cost-effective, and with the same performance or better than what we had with Gluster. This is where Amazon EFS stepped in and was a real win for us. Not only was it able to meet all of our application needs, having a fully managed elastic file system simplified our approach and resolved our operational challenges at the same time. We still had one last hurdle to go: NFS group limits. The Gluster protocol allowed for requesting users to belong to upwards of 90 groups, where NFS has a hard limit of 16 groups for the same users. For some of our largest multi-tenant clusters, we relied on this behavior, and it was a problem we had backed ourselves into over time. The Amazon EFS team was able to take our feedback on this and deliver a way forward. Taking advantage of EFS Access Points, we were able to change the way we interacted with the file system paths and, in the process, enhance the security for things like backup, tasks interacting with these multi-tenant clusters. Another aspect we really appreciate about working with AWS is their commitment to the Kubernetes ecosystem. Building on the Kubernetes container storage interface, the Amazon EFS team has created a driver for EFS that simplifies the management of common file system lifecycle events, enables native Kubernetes API calls and capabilities. With this, we are able to use standard Kubernetes persistent volume definitions to easily secure and attach multiple application-specific data paths for a single EFS file system. I would encourage anyone using or interested in using Kubernetes on AWS to take a look at the driver and simplify their persistent storage needs with Amazon EFS. As we continue to evolve our services, partnering with Amazon EFS has given us all of the benefits of an integrated, cost-effective, scalable POSIX file systems our workloads needed, while considerably reducing our infrastructure setup and operational maintenance overhead. Thanks, Will. I really appreciate the collaboration and all you and your team have done. Keep it up.
Thanks, Jake. It's been really exciting working with you and seeing what you've done with your infrastructure. So to wrap up here, I want to make sure that you're all aware, if you like this session, there are many other sessions at this reInvent about EFS. If ones that might be relevant to you since you watched this session would be the deep dive on EFS, modernizing applications with AWS Lambda and EFS, and security and performance best practices. I thank you again for joining us today. Best of luck in modernizing your infrastructure using containers and EFS. Enjoy the rest of your reInvent. Thanks.